Next up is number 6. If events A and B are mutually exclusive, then events A and B have outcomes in common. So that is not true. If they're mutually exclusive, they simply do not have anything in common. They also do not overlap, so that's not true either. If I look at C, A and B cannot occur together, that seems like the most reasonable answer. So far, events A and B make up the entire sample space. That is not true, because we could have events A, B inside this space, and then this is neither A nor B outside. So you could have two mutually exclusive events, but there are other things that can happen besides A and B, like C, D, E, or F, or whatever. So they don't occur together. So this makes D incorrect. So the answer is C. C. Okay. 7. Miss Lutz plays this or that with her students. She asks them two this or that questions, and each student chooses the item they prefer in each question. She then asks her students to choose between text or call and Facebook and Instagram. So the table shows the results. One student is randomly selected. Okay, now we're looking at this two-way table. First thing I want you to do is pause the video and write the totals and write up a two-way table on a sheet of paper and see if you can try these problems. Okay, so the first thing I did was I filled out the totals here, and it seems like, if you just look across the bottom, we have that, and this is the grand total, 37 total students. First question is, what's the probability the student chose text? So I look at the total text people. If I go down, this is 32 total people out of the total group that chose texting. That's 37 total people. So the probability text is equal to 32 out of 37. The next one, if the student chose text, what is the probability they chose Facebook? Okay, so now I'm looking only at text. So I'm going to cover up the call side of this thing, and I'm going to look only here at this box right here. Well, I'm also going to include the total. Okay, so if the students chose text, what's the probability that they chose Facebook? Okay, given that they texted. They prefer texting to calling. So what is that probability? That equals the total has to be 32 because that's the total of texters, and the probability of Facebook would be 14 out of 32 because there's 14 out of these total 32 people who text. Out of the people who text, 14 of them prefer Facebook. Okay, the next one. Given that they prefer Facebook, what's the probability that they chose text? Okay, so given that the person likes Facebook, okay, so now I'm covering up everything, so I'm only going to look, and I'll make this in red so we can look at it a little differently. So if I'm only looking at this column, or this row here, okay, the Facebook total, that means the probability, given that the student chose Facebook, what is the probability they chose text? So I want probability of text given that they chose Facebook, okay? And that's going to be, if I cover up everything except Facebook, that means the bottom of the fraction is going to be 16 total Facebook people. Out of those, 14 chose text. All right, problem 8 is a tree diagram problem. The tree diagram here is set up for you, and there are two different routes that Matthew takes when he drives to school, Route A and Route B. So Matthew starts, he's going to go either Route A or Route B to school, and then he's either going to, it looks like he prefers Route A, which he takes 60% of the time, and when he takes Route A, he arrives at school 80% of the time on time. When he takes Route B, he arrives at school on time 90% of the time. One quick note, I wrote over here the formula for probability of A given B, okay, just in case we need it. Probability of A given B is over here on the right, okay. So the probability of A given B is right over here on the right, and it's basically the probability of A and B, which will be like A and B, or something like this, whatever those two probabilities are, divided by the total probability of B, which we have to add the both of them. So we'll see what this looks like in just a moment, hopefully. Okay, complete the tree diagram given by labeling each branch with the appropriate probability. And we're going to go ahead and calculate them as well. So pause the video and do that yourselves. If you've already done it, just keep playing. Okay, so I went through and I filled out the table, and I'll just take you down a couple of these paths. You can pause the video and just look at this if you want. But this is 0.6, so this has to be 0.4. And then this is 0.8, so this has to be 0.2 late. Okay, 0.9 is on time here. 0.1 would be late here. So I just followed all the paths and I multiplied each of the probabilities. Okay, and I got 0.04. So now I've got all my probabilities laid out, and then we're going to complete the given tree diagram by labeling each branch and completing the probabilities. So I went ahead and did all that, and I made sure the total was 1. Yay, it worked. Okay, what is the probability that Matthew takes Route A and arrives on time? So if I go Route A and arrives on time, that's 0.48. So I've already calculated it. I know, if you show your work there, you don't need to show it again. It's 0.48. Okay, and then what is the probability that Matthew arrives on time? Okay, the probability that Matthew arrives on time is the two probabilities that he arrives on time added together. So I'm going to take this 0.48 plus 0.36, and I'm going to add that together. I'm going to go 0.48 plus 0.36, and I get 0.84. So 84% of the time, Matthew arrives to school on time. And that's the problem. Okay, a dealer shuffles a standard deck of cards and you draw 2 cards. There are 13 hearts in a standard deck of cards. Okay, so we're going to go hearts or no hearts, and that's what we're going to look at for the entire, looks like the entire problem. So we're going to complete this tree diagram. We're going to draw, what is the probability of a heart? Well, the probability of a heart, actually I don't want to do that there. The probability of a heart is equal to 13 out of 52, which is 1 out of 4. So I'm going to write it as 13 out of 52, okay? And that is the probability of drawing a heart. The probability of not drawing a heart is 39 out of 52, okay? Because that's 52 minus 13. So whatever is left in the deck is not a heart. So you've got hearts, clubs, spades, and diamonds. So there's the rest of them are either hearts, clubs, or diamonds, okay? All right, now, once I've drawn the probability that I get a heart on my second draw, well, now I have to look at what is going on with 2 different things. So here, I drew a heart. So what's left in the deck is 51 cards. How many hearts are there? There's 12, so this will be 12 out of 51 cards are hearts. Okay, over here, not a heart. There's still 39 non-hearts in the deck, but now 51 cards in the deck, okay? All right, now 39 cards out of 52. If I do not draw a heart on the first go, then I draw a heart on the second go. That will be the same number of hearts are still in the deck that I started with, which is 13, but 1 less card is in the deck because I drew out a non-heart card. Okay, so I actually drew a card out like the 6 of spades, and I still have 13 hearts in the deck. All right, that means there's 1 less non-heart in the deck, so this will be 38 out of 51. Okay? All right, now we're going to finish our probabilities. I'll pause the video. You go ahead and complete the multiplication. Okay, I've gone ahead and completed the branches, and I'm following the paths. For example, I wrote this up as this is heart, heart. So heart, heart would be these probabilities. Now, these can be simplified. This is actually 1 out of 17, but I'm going to go ahead and leave them as this. These giant fractions, they're kind of ugly. I can convert these to decimals if I want, but I'm just going to keep them like this. Feel free to do that with your calculator if it makes you more comfortable. Your TI-84, if you have one, will also reduce these fractions if you multiply them as fractions, and it will. So for example, this right up here is 1 out of 17, which would make your life probably easier. But anyway, we'll just leave them like this. But if we go heart, no heart, that would be heart HN, which is heart, no heart. And then this would be no heart, heart, okay? And no heart, no heart, which is this probability. Okay, All I did was multiply, follow the path, and multiply the two probabilities. Okay, probability you get a heart on the second draw. Okay, so that is wherever there's a heart, heart or heart here, okay, on the second draw. So I need to add these two probabilities. I'm going to take 156 out of 2652. I'm going to take 156 out of 2652 plus 507 out of 2652. And that should equal 156 plus 507 is 663 out of 2652. And if I actually calculate that, it's actually 1/4. And that should make sense. It's a 1/4 chance of us getting a heart on the second draw. It's not an illogical conclusion, all right? But we had to add these two because this is where there's a heart in the second draw and a heart in the second draw. So I need to add both of these probabilities as multiplied. Nothing over here. We're not concerned with that. We're going through the whole process and then we're saying, what's the probability that the heart was drawn second? Okay? Now, given you get a heart on the second draw, what is the probability you did not get a heart on the first draw? Okay, so let's write this up in sort of probability language, and we're going to use that formula, probability of A given B equals the probability of A and B divided by the probability of B, okay? And so given that you got a heart on the second draw, okay, so that's going to come second in our probability statement. So the probability, no heart on the first draw, given heart on the second draw. Okay, so now I've got heart on the second draw. I got probability of no heart on the first draw, given heart on the second. Okay, so we got heart on the second, which is this 663 out of 2652. Okay, so now I take heart on the second draw, which is the probability is A and B. Probability no heart on the first draw, which is 1482. A correction, 507 out of 2652. And we're going to divide that by 663 out of 2652. Okay, so this is going to end up being 507 out of 663. Please use the calculator. And it makes sense because the chances of getting a bigger card is or a non-heart card on the first card is way bigger than it is getting a heart. So the chance of getting a heart is only 156 out of 2652, 1 out of 17, whereas the rest, getting a no heart is way higher, 507 out of 2652. So 507 out of the total probabilities, 663 possibilities of getting that it just makes sense. Okay. And just to clarify this, the probability of no heart on the first and given heart on the second, we're going to take probability of no heart on the first and heart on the second, and we're going to divide that by probability of heart on the second. Okay, that's the formula right up here that I've wrote, okay, right up here. So just to clarify, this number right here is the probability of no heart, which is that 507. So that goes on the top. No heart and heart second goes right here. And heart second, which is this 663 out of 2652, goes on the bottom. So that's where these come from, all right? Okay. Okay, at the Probability Ice Cream Parlor, your treat may be unexpected. To select ice cream flavors, For a double scoop cone, you are handed 5 index cards. You write chocolate on 2 of them, vanilla on 2 of them, and peanut butter on 1. The cards are placed in a bag and shuffled well. You select 2 cards at random, and those cards are the cards, those are the flavors you're gonna get. So using this system, what is the probability you will receive a cone with 1 scoop of chocolate and 1 scoop of peanut butter in either order? Okay, so we have 3 possible flavors of ice cream we can get. So we're gonna draw this scoop, okay? Oh, why is this playing with me here? There we go. Okay, so I've got 3 possible scoops of ice cream. I've got chocolate, and I've got peanut butter, and I've got vanilla. Okay, so the chocolate is 2 out of 5 of the cards. The peanut butter is 1 out of 5 of the cards, and the vanilla is 2 out of the 5 cards. Okay, now what happens next with vanilla? I don't care, because that's not even a concern for us, because we're just looking at what is the probability that we will receive 1 scoop of chocolate and 1 scoop of peanut butter. So I'm just gonna pursue the chocolate and peanut butter trees. I can pursue this if I want with vanilla. You know, I still could get 3 possible flavors here afterwards, but let's go ahead and do chocolate. What happens if I choose chocolate first? Well, then I can get either chocolate, peanut butter, or vanilla. Now, if I choose the card that says chocolate, that means for chocolate, there's only 1 out of 4 cards left. For peanut butter, 1 out of 4 cards left. That's peanut butter. And then vanilla, there's 2 out of 4 cards left. Okay? So for peanut butter, same thing. Vanilla is going to be 2 out of 4. Peanut butter, 0 out of 5. So only left is Choco, which is 2 out of 4. I could put peanut butter 0 out of 4, but I'm not going to, just for the sake of the space of this diagram. Looks like I'm a little jammed up here. But now I'm gonna go, now I've got what I need, because I've got peanut butter, Choco, and I've got Choco peanut butter. That gives me both of the 2 probabilities. Once I've computed these 2 probabilities, I'm simply going to add them together. And so I need to multiply across. I'm going to get the probability of peanut butter, then chocolate. This is 1/5 times 2/4, which is 2 out of 20. And then I'm going to do the same thing, 2/5 times 1/4, which is 2 out of 20. 2/5 times 1/4 right here is 2 out of 20. So this is 2/5 times 1/4, which is probability of chocolate times the probability of peanut butter after I got a chocolate. And this will be 1/5 times 2/4, which is peanut butter, probability of peanut butter times the probability of chocolate, given that I got a peanut butter. Okay, so now I've got 2 out of 20 and 2 out of 20. This is chocolate peanut butter, and this is peanut butter chocolate, okay? And I just add those 2 probabilities for the total probability that I get 1 of each, which is 2 out of 20 plus 2 out of 20. I can't write it, but it's 2 out of 20, which is 4 out of 40 total. Excuse me, not 4 out of 40, 4 out of 20, which is 1 out of every 5 chances of playing this game, I'm gonna get a peanut butter and a chocolate ice cream, okay? All right, and that is it for this practice test. I hope this helped. I hope this video was helpful. Thank you for watching to the end, and have a nice day.